Section 5.1, number 16, we could do this a really, really long way, or we could do it a really, really short way. The really, really short way, I think, would be dealing with the concept right here that if we're trying to prove that f prime of 3 does not exist, we're saying that this function does not have a tangent line right here at the spot where x is equal to 3. And the simple reason for that, guys, if you remember in our notes, we talked about the 4 ways, informal ways, that a derivative might fail to exist. This one right here is what we call a corner. We have a tangent ray to the left that would look horizontal over here, meaning that, again, if we just want it to be informal right here, our left-hand derivative at x equals 3, the slope of that tangent ray we just drew would be 0. But if we drew the tangent ray going to the other side, we see this as part of a linear function here to the right, there we would find that that slope is not 0. The left-hand derivative at x equals 3 then is going to be, and let's see, all of our scaling is right, yeah, that's going to be a slope of 1/2. And as soon as the left-hand derivative and the right-hand derivative are not equal to each other right there, we can say that the derivative, f prime of 3, does not exist. So that's what we've kind of established there informally. F prime of 3 dne. The more formal way of doing it, and I'm not going to take the time to do too much of this, would be that for a left-hand derivative, what you're really setting up here, guys, is a limit as h approaches 0 from the left of the formula here for f of x plus h minus f of x all over h. And for your right-hand derivative, this would be the limit as h approaches 0 from the right of that same thing right there, f of x plus h minus f of x all over h. The difference being the functions would be different. On the left-hand side right here, f of x is a constant function that's just equal to 1. So that's what you would put here for f, and you'd use it for f of x plus h2. And on the right-hand side right here, f of x would equal, well, what do we have here, guys? A linear function with a slope of 1/2 that I'm pretty sure would have a y-intercept of negative 1/2. So that would be y is equal to a 1/2 x minus 1/2. That's the function you would need to use for the right-hand derivative here and here. And I think when you did that, you'd still find that this one ends up equaling 0, this one ends up equaling 1/2, and again, it's the same conclusion. If a question like this were to show up on a quiz or a test, I would let you guys get away with the informal process. You just need to label what it is that you're thinking at each spot there and those values of 0 and 1/2.